Hello, everybody. Welcome to Introduction to GitHub. I'm Chris Ciccone. I am a MCN member since 2015, and I'm really looking forward to this session. First, I'd like to, hang on a second, I've got to find my, I'd like to thank Microsoft Registration Assistance Fund sponsor, Axial, Ignite sponsor, and all the other sponsors listed on the program schedule. And I welcome you. And here we go. Okay, so do we have slide one up? Okay. So this is our old title for today's session, but we've had to make a few changes as Jerry Moore can't be with us today. So MIA software architect Kjell Olsen has agreed to step up and help. And sorry, I'm looking at this on a separate thing, sorry, okay. Okay, so Kjell and Charles have revised the session. It's now Introduction to GitHub with an expert and an amateur, but it's still for cultural heritage professionals like us. Kjell Olsen is a coding cultural heritage professional here to share the benefits of using text-based formats and Git to create and share content more broadly. And Charles Walbridge is lead collections photographer at the Minneapolis Institute of Art, or MIA. He's worked at MIA for more than 15 years, and the work he does, including still photography, 3D scanning, conservation photography, image data standards, and environmental sustainability. And I would like to add on a personal note that my first MCN was in Minneapolis, and I attended a really great photogrammetry workshop in the MIA photo studio, and that's where I met Charles for the first time. So I will turn it over to you guys. Thank you very much.
Thank you, Chris.
Thank you, Chris. Good morning. Hey, I'm Charles. I use he, him, his pronouns. I am, as a description, I'm a middle-aged white guy with short brown hair, and my beard used to be blonde, and now it's mostly gray. My virtual background is the photo studio at MIA, where I am not. I'm actually in my basement office. I wanted to do this session because I wanted to have a basic understanding of GitHub and how it flows. And I don't actively have a need for it in my work right now, but I can see how it's really going to be useful for me. And I know from Kjell's work that we use it a lot at MIA, and so I want to know more about it. And again, Jeremy sends his regrets. The GitHub, one of the GitHub repositories that he's working on is called Coding for CH, and it's one of his many projects, and he's using it to share code that might be useful for like archive mass digitization. So let me know if you want to talk more about that. And let's go forward, Kjell. Today in our session, we'll talk about GitHub concepts, and then we'll follow a super simple project just to see what steps you might go through and what the interface looks like. And then we'll bring some new contributions into a project to make sure it works. And then we'll try to go live and have all of you or a few of you contribute to the project. So if you're watching the slides now, you can just follow along, even if you don't try to set everything up for yourself on GitHub right now. And if you're following along, you can log in, and we'll do our intro, and we'll show that project, and then we'll ask you to actually contribute to that project. We think we'll be able to pull in your contributions through GitHub and also from the chats, and we have confidence that will work when we go live. But we'll leave this project open today and tomorrow through the end of the conference. So we'll aim to keep pulling in new content until at least then. We don't want to get bogged down in getting every single person to contribute to the project in the next hour. So if it's not working, try the chat and the Q&A, but don't stress about it. And let's go over to you, Shell.
Okay, hi everybody. I hope that everything here is working with the webinar. You should be seeing our slides and my little virtual head up in the corner. My name is Kjell Olsen. My pronouns are he, him, they, them, and I am a software architect at the Minneapolis Institute of Art, where I work on the website, sort of database, data transformation things to get everything that the museum has out into the world for people to see it. I'm going to spend a few minutes talking about Git, which is a program for managing versions of things, and GitHub, which is a platform built around Git to centralize sharing and collaboration on projects. This is a really interesting topic to me. I work with Git all day, every day, and it has some really huge benefits to the work that I do and how I keep track of what is happening. That's coming from a software development background, but it's also really relevant to developing any sort of content, any sort of authoring or editing project that I see a lot of them happening in my museum in different ways and different workflows. And we've tried using Git in a couple of different ways and had some successes and some failures with larger teams. So we can talk about that a little bit at the end too. What is Git? This is the Wikipedia version, the definition of what Git is. It's sort of jargony, and I'm going to go through each of these terms in bold to dive into the important features of Git. It's a computer program that you download it on your computer like any other program, and you run it alongside projects that you're working on to manage files. It was created about 15 years ago, and it came out of the project Linux, which probably everybody right now has a device somewhere within 5 feet of them running the operating system called Linux. Linux got to be so big and so complex that they ran out of version control systems that existed 15 years ago. There weren't enough good options. So they actually sat down, the developers of Linux, and they created this system called Git. Primarily because they wanted it to be fast. They needed something that had a free license. The system they were using before they wrote Git had some copyright problems crop up to switch from it. And there weren't any other adequate options. And they decided they would just go ahead and they would write their own system. So Git is a distributed version control system. It sort of looks at all the stuff that you've got in your project, mainly files built out of text, commands and lines of code or lines of writing, and it keeps them all together. It tracks different changes that are happening. Doing software development means you're constantly going in, sort of changing things, making new features, writing new lines of code. And so that's a lot to keep track of, even for one person. And then when you get to a project like Linux, which has hundreds and hundreds of diverse contributors, that's just impossible to do. The way that it used to work in software development is you would sort of talk to your colleagues or your coworkers and say, okay, I'm working on this file, so nobody else can work on that file. You would do something called a checkout. You would say, this is my file, I'm checking it out for the day. I'm going to make some changes to it, I'm going to work on it. And when I'm done, I will check it back in. And then it's sort of open for anybody else to go in and look at. And that just doesn't scale. That doesn't work on a large project. So Git is a system to sort of streamline that flow of managing who is looking at what pieces of source code in a system, who's making changes to them when those changes happen. And here, this definition is talking only about source code, but it applies equally to any sort of source content. So it can be source code, it can be lines of code that are building a software project, but it could also be your writing regular English language or other language documents. It could be a website with all the web pages and their content, their images. It also is really good at tracking changes in any sort of plain text file. So that means you can capture data in it really well using data formats that are primarily based on plain text. You can even track Word files or Illustrator files or videos or images. Git has some special features, and you can build special plugins for Git that know how to go into specific file types and really understand what that file type is and how to track small changes in different files. So it has a lot more applicability than just for computer programmers writing source code. The thing that it is really good at is this idea of tracking changes. So one day you have a project and you sit down in the morning and you're going to work on that project a little bit. You're actually making all of these changes, some small, some big, some things are moving around, maybe some things are staying in the same place but being changed. When even working by yourself, Git is really useful because it captures all those changes and how they're happening individually, but also as a larger group. So it makes it really easy to see from version A to version B what has changed. And then another big thing of Git is that it is focused on enabling non-linear workflows. This doesn't mean that it is bad for following linear workflows, but that it's trying to go beyond the idea that there's a single pipeline of unidirectional changes happening. So a lot of the content editing that we do in the large organization that I work for is sort of a traditional editorial publishing system where somebody writes content and then they send it to somebody else and that person edits the content. Then they send it to somebody else and that person edits the content again. And it kind of goes down the line. One person at a time is working on any given article or project. And once that project is done, it's sort of wrapped up and it's finished and it gets put on a shelf, it gets printed in a book, or it gets created as a website and it's set in stone more or less. So there's no part of Git that makes that hard. That will work just fine using Git, but Git was created primarily to serve a workflow where things are kind of all over the place. People are making changes. Maybe nobody even knows who that person is. There needs to be a really serious review process for every change that happens, and changes need to be able to lay in on top of each other. So one change might get made and then another change that started off on an older version now has to incorporate the changes that have happened in the meantime from when it was originally started and to when it was finished. So it doesn't necessarily go from A to B to C. It could go from A to C to B to X in sort of a very jumbled workflow. And another part of that is that a lot of these projects are distributed. People are all over the world or all over in different fields. They're not all necessarily primarily working on any given project. Someone might step in for one small change that they want to see in a project and just sort of offer that up as an opportunity for the people maintaining the project who are focused on that one project to incorporate it or not. They're just saying, this is something that I found useful. I want to send it in to you in case you might find it useful too. And there's a whole process that goes along with that, with saying, well, maybe it's not useful to us, but we can see how it would be useful if you do these 3 or 4 things. And it sets up a whole dialogue of back and forth on how can all of these changes be merged back in the best way possible. So to wrap all that up, Git is a program. It's like a lot of other programs. You kind of just download it onto your computer, and it serves to enable this distributed version control system within the projects that you're working on. It tracks changes in files and in groups of files. So a project is essentially just a folder with a lot of files in it. It looks at all the changes that get made from one version to the next. It also keeps track of who made those changes and when did they make those changes. And it's really good at when there are a lot of different changes out there that are floating around, and maybe some of them conflict with other sets of changes. One of its specialties is to merge changes back together seamlessly, so nobody's work gets lost. Everyone can kind of have their own version of the project. And when they go to merge all of those versions back together, there's a whole process for recombining things in a way that doesn't step on anybody's toes. I think the metaphor that really worked for me is using Git as like attaching metadata to each step along the way as you go building a project. There's a concept called a commit, which is kind of how we'll talk about that in a minute here. Each step of the way you commit your work in little bits. So it's a way of sort of journaling through the progress that you're making and recording little journal entries or diary entries. And it means that when you go back to look at a project, the way that those changes happened is made very visible. There's a log of all the changes that have happened from when the project started to the point that it's at right now. And it's like a way to digitally archive your daily work process. And so those are all of the really great features that Git has. There are some downsides. It was built by a bunch of computer programmers, which means that it's extremely complex, and that makes it pretty hard to learn. The learning curve is steep. I have said that it's a program that you just download to your computer, but it is a command line interface. So you download it on your computer, but the only way that you can really, the first interface that's presented to users is typing commands into an obscure tool used by computer programmers. And that's pretty hard. So this is where we get to GitHub. GitHub is an online platform that was built around Git to sort of wrap up all of those rough edges to make it a lot easier. When GitHub first launched, its motto was to enable social coding. So people who are doing this computer programming work could kind of showcase their projects, share them with other people, and everyone could they could come together and work on things. In a lot of ways, it's like Twitter or Facebook for computer programmers. You get a profile picture, you set up some basic information about yourself, and then you can put all your projects up there and go find all of your friends' projects and help people work on things that they're interested in working on. So some of the great features of GitHub is that if nothing else, it's a place that you can back up your projects. Git makes it really easy to send the work from your local computer all the way up to GitHub and have it hosted there and go back and forth. Having the work up on GitHub makes it really accessible to other people who are browsing through or interested in contributing to a project. And then, like I mentioned a minute ago, it provides a really insightful history into how a project works and what's happening. And it can be a great learning tool even to go in and look at how somebody else is doing something. It's all it's almost like you can rewind in the history of a project and press play and see exactly how something was built. And GitHub is one example of this idea of a platform built on top of Git. There are a lot of other companies that run their own versions. We're going to focus on GitHub here because it's the most commonly used. Most people know what it is, but there are a lot of alternatives out there. So we don't want to give the idea that GitHub is the only thing available for these uses. There are a lot of systems that you can sign up, log in, and have a place to do these same tasks. So that is a really quick introduction to what Git is and what GitHub is. And now we will move to Charles to talk more about it. Charles, are you muted? I think.
Thank you. Thank you. I tried unmuting myself just a minute ago and I couldn't do it. And so I knew I was stuck here all by myself. So moving on to GitHub concepts and terms, a repository is the most basic element of GitHub, and it's easiest to imagine as just a project's folder. It contains all the project's files, including its documentation, and it stores, like Kjell was just saying, all of each file's revision history. And repositories or repos can have multiple collaborators, and they can be public or private. And you will, when you're looking at a repository in GitHub, you'll see it as a top level in the GitHub interface, and you'll see the files that it contains. And a commit is the, oh, sorry, we're moving on. A commit is the most basic element of Git. Is the next most, it's not the only basic element of Git. It's a group of changes that are somehow related, and they come with their own metadata. That's the commit message that describes their content. Each commit is saved in GitHub's database, and importantly, so is the relationship that commit shares with all the other commits. And in the next slide, we have an example of a repo from Mia, and this this shows us that our username is artsmia, and our repository name is collection in this case. And we're looking at the master or the main part of the repository, and it contains folders and documents, including readme.md down at the bottom of that little window there. That's displayed as a file icon, and it's also displayed, its contents are displayed at the bottom of the window. And the middle column of that central panel shows you the most recent changes, the commits that have happened to that file or folder. And then next up, we have a branch. And a branch is a parallel version of a repository. I'm waiting for my slide to catch up with me. A branch is contained within the repository, and it doesn't change the primary or the main branch, and it lets you work without disrupting the live version. When you've made the changes you want to make, you merge it back into the main branch. So when you make a main branch, you take the entire repository, that most of the time the folder and its contents, and you make your own copy of it. Then you do your work in your own branch, and when you're ready to bring it back in, GitHub will check to make sure you can put everything you've done into the main repository without any conflicts. If you can merge without messing anything else up, then the owner of the repository can accept or pull your changes back into the main branch. And if you can't merge without messing things up, then you have some discussing to do with the owner of the repository, and GitHub has tools for that as well. Next up, for concepts and terms, we have Markdown, and Markdown is a simple file format and text approach like doc and RTF and TXT. It's easy to just type in plain text with just a few extra characters to call out what you're doing. GitHub's Markdown is called GitHub flavored Markdown. And we have a couple examples of that for you. So like you've seen in many other formats, you use a single hashtag for big headline and multiple hashtags for smaller headlines, asterisks for italic text, and a couple of colons to separate out any of the emojis that you can think of, as long as you know how to spell them. So Markdown will actually show articulated lorry as this little tiny semi-truck. And Markdown is particularly useful in GitHub because every repository has that readme.md file, and GitHub reads this file and it displays it to you in the main directory of your repo. And here we're in the same repository that we saw before, and we can see that the master branch of this repo contains 3 folders and 5 documents, the last of which is readme.md. And then the README doc is displayed with its Markdown rendered as links in bold text and so on further down in the view of the repo. So this is the actual raw text that's in the Markdown of that file. And so you can see that Shell has used square brackets and parentheses to call out websites. The greater than symbol calls out a line of text. And the double pound sign plus Y becomes a headline. And now here's our simple diagram of the flow in GitHub. And we'll show this in action in a few minutes. And our code or our text or our project is moving from left to right in this diagram. And the main branch is the one that everyone is working on. Just in October of this year, GitHub finally switched the name of the main repository from master to main. And so you might see in old instructions and repositories where they're still using the old terminology, but everything that you make that's new will use main instead of master as the primary branch. And so our line breaks off here because you have an idea for a change. And so you make a feature branch from the main repository. And now you're working on your own copy. You write your own changes. And when you're satisfied with them, you let the owner of the repository know they're ready by submitting a pull request. And then you're asking them to pull your changes into the main repository. If you need to, you discuss your changes, and then when the owner of the repository is ready, they'll pull or merge your changes into the main repository. And then your change is part of the main branch going forward.
Charles,
Yes.
there's a question from one of the attendees.
Yes.
George asks, is there a max file size? For example, if I wanted to host a website with a pop-up video, can I host the entire thing on GitHub and buy a domain name?
What does the domain? I'm trying to think how the domain name will catch up with that. And let's make sure about that with Shell. I don't think there's a maximum file size for GitHub, but it gets, like we've considered loading a lot of 3D data onto GitHub, and it at this point it's not practical just for storing files. So let's ask Shell about that, because our next slide is him talking and additional concepts that GitHub has added to the Git flow. So
I can, there is a maximum file size that GitHub sort of enforces, but doesn't really enforce that hard. Git is designed to host mostly plain text files. So when you start putting images and videos into your Git repository, it takes away some of the speed, the advantages that Git has around being really fast at the things that it does. So you can do that. And I saw Greg in the chat chime in. There's sort of an add-on service that GitHub has built where it allows you to host any size of file you want. And it sort of adds a layer to get the program running on your computer to manage those files a little bit differently than it manages normal Git files. And then because it's all tied together with GitHub, they can also count how many megabytes or gigabytes or terabytes you're storing and charge you adequately. So that's all part of GitHub's commercial extensions to how Git works. So that is possible. And there's also, GitHub has a service called GitHub Pages, which is used to create websites, web pages, and hosting. We're actually going to talk about that in about 15 minutes. And it does have a way that you can add a domain to your website and host it all within GitHub. And it's a pretty cool system. So we can talk more about that at the very end, but we'll give you a little preview of how that works here in section 2 of our presentation. So Charles did a great job of talking about GitHub and sort of what it adds to the obtuse version of command line Git that a lot of computer programmers like me run every few minutes when we're working on a project on our local computers. The big thing that it does is it really it makes it easy to work with a lot of other people, because it takes everything out of a text-based user interface and puts it up on a website with excellent user user-centered design. I mean, maybe not excellent, but very good user-centered design to make things easier and make people kind of go through this flow that Charles explained, where the idea is you're always starting from the main branch of a repository and then kind of creating your own copy of that project and making any changes you want, and then submitting those changes back to the people who are in charge of the project. You can kind of go through this is called a pull request. And it's a process of saying, here's what I'm working on. Can you review it? Can you give me pointers? Can you give me some direction on how I should continue working on this? And then at the end of that process, everyone gets together and they say, this is looking really good. Let's get this merged, is sort of a phrase that means we're at a good place. Everything is compatible now between this new change and the existing version of the software. Let's bring them back together. Let's merge them back into the main branch so that this new feature is now a part of the overall project and everyone can get the benefits of it. GitHub adds some other features like issue tracking. So if you have a problem, you can go to GitHub and you can switch from the code view of a repository to the sort of problem view or question view. The issue tracking view, you can just post an issue with the repository and the people who know how to deal with that issue will come in and they can answer your question or help you fix something that's not working. It's also this platform where a lot of people have accounts, and it's kind of it's the place where people go by default to look for new software. If I'm working on a project and I need something specific, I might not want to build that myself. And there are probably a lot of projects on GitHub that are tailored to doing what I want to do. So then I can go look at all of those and say, this one looks like it will fit exactly what I want to do. I can evaluate it. I can browse through its GitHub activity, its issues, and see if it looks like something that I will enjoy working with. Then I can grab my own copy of it and build it into the projects that I'm working on. We've talked about branches, which is one way to copy an existing project into your own little sandbox. There's another concept that's very similar called forking. And what a branch is a different version that stays within the same repository. What a fork is creating a copy of the original repository and making that my own individual copy. So at a simple level, to make a simple change, I can create a branch of a project and work on it and send those changes back into a branch. On a team, when you're working with your own trusted colleagues, most people don't fork a repository to make different changes. The project team works within a single repository, creating branches that then other people can jump in and collaborate on. But when you want to kind of take a project and really make it your own project or make your own version of the project, you can also do a very similar copy, but instead of creating a new branch within the existing repository, you actually create your own independent repository. But some of the cool things that Git does means that there's still seamless interoperation between two different repositories. It's very easy to take a branch from one repository, make a pull request on that branch, and send it back to the original repository. So, Charles.
Oh, sorry, back to me. I was taking that question from the chat and moving it into a slide later, but I'll do that in a minute. Let me just paste this. Let's follow here. We're going to follow some simple changes in a repository. And let me minimize this chat window. In our next slide, we're creating a file called, Kjell, will you advance that slide?
Yes.
Here's our little screenshot of us creating the file called basho1 inside a repository called MCN haiku test, and we're filling it with a basho haiku. And as you can see, it's the first 3 lines in that new file that we've made. You can see that because they're numbered. And then in the next screen grab. We've had GitHub compare our new file. Will you move ahead, Shell? We've had GitHub compare a new file to the whole repository to make sure it doesn't conflict with anything. So it's showing us all the changes it can detect, and we're seeing that in green, we've changed a file by creating it, and it's got 3 additional or new lines in it. And notice that it has 3 little green squares right there, because that later gives us an idea of the size of the changes we're making. In the next slide, we've added another haiku to the same file, and GitHub is telling us that there are 4 additions, including that empty line, line 4. So this is how you visualize the additions that someone wants to make to your repository or to your file. And in the last one of this super simple workflow, we've deleted the haiku that includes the swallow, and so that has become red, and we're adding the dragonfly haiku, and that appears to us in green. You can see that the line numbers are the same, which is another indication that we're replacing a haiku and not adding a 3rd one to this file. So that's a simple visualization of the things you see when you're collaborating in GitHub. And sorry, you can't see the indicator here, but there's a space within GitHub where you can see what all the previous changes were, and you can roll back to them if you want to, and that's super handy. So that's our super simple visualization of the change workflow. So let's either take questions now or see that in action for a couple of minutes. And yep, I pasted that one into our notes, Shell. I'm just going to read it to you. How does GitHub inform about intellectual property if I make use of an existing project or content out there? And Shell's got a good answer for that, I'm sure. Or I know he does. Yeah.
So yeah, that could be a whole entire presentation, but a lot of GitHub is centered around this idea of open source code. So most repositories will have an explicit license attached to them that says how you can reuse the code. So that's one way, is a lot of the code is out there. It's intended to be shared. It's easy to make these branches and forks. So the license file is kind of, it's treated similarly to the README, where you put a certain license into your project, and GitHub attaches that to the whole interface that it has. And as far as intellectual property goes, there's a whole legal framework that was in the news actually very recently around American copyright law and what happens if someone has posted copyrighted content on their GitHub that belongs to me. I can go and I can make a legal claim to GitHub that that is infringing on my copyright, and GitHub then has to obey American copyright law about what they do next. But that's a whole other complex system that I don't really want to get into in this chat. There are systems in place to handle that.
Cool. And I've taken the other question out of the Q&A, and I've moved that to our questions slide at the end. So we'll move forward with that.
Okay. So we've sort of indicated that we're going to do this little project, and the idea that we came up with is to make a collaborative haiku generator. So we've got a project set up on GitHub now. We'll share the link to that in a second. I'm gonna have to figure out how to change my screen to share that project instead of these slides. So it'll take me a second. Charles, do you want to talk through a little bit?
Yes, and I'm going to find the
sharing switched.
I have the I think this is the random haiku URL. That looks right. Okay, yep. And then the other link that I have, let me see where my chat is. This is, that's not it. Hold on, I'll be right back. We'll get there. and I'll get that into the chat.
Okay. Does everybody see
I'm making,
MCN 2020 Git haiku?
yes.
Okay.
And
So
here's,
this is the little playground we've created so that everyone who's interested can go test out some of these features. It's a repository on GitHub that we worked to host under the Museum Computer Network GitHub account. And it has a README MD file with a haiku and a picture of this famous haiku poet named Basho. And this haiku here actually is not a haiku by Basho. I wouldn't want to embarrass him by claiming that he wrote this. This is a randomly generated haiku recombined from different haikus that Charles found. And so we have a folder in this repository called haikus with a few Markdown files. And these Markdown files have Basho haikus in them. And what this repository doing is reading all these haikus and shuffling them together and then recreating a semi-randomized haiku. You can see here is the raw source of this file. It has a list of 50 Basho haikus. And what we're going to ask people to do here in a second is to log into GitHub, go to this repository and create their own haikus. And we have a few examples that are ready to go here. And we will, as we see these come through, go to the pull request page that GitHub creates and start merging these so that everyone who's interested in participating can have their own haiku included in this repository. So as I was talking there, I just went to this pull request that was created, Charles, with a haiku from Carla. We can look at what was different about that. And it says that there were changes to these two files. This file here, haikus/carla.md, was added with a unique haiku, and there's some other changes. And if we go back and look at the main page of the code, we'll see up here that the latest change was to merge pull request number 5, which is the one that included that haiku from Carla. If we go into the haikus folder, see there's now a file called Carla MD. And the next step to this is that we also have this repository set up to build a web page that's based on these haikus. And whenever a change is made in the repository, it will update this website with a new random haiku. So here's the example of the haiku. We can go in and find another pull request and read a little bit about it. We can look at what files have been changed. We can see here's the example of a new haiku. As we're doing this on a large scale with everyone participating, we want to remind people of the MCN code of conduct to make sure that nobody is submitting content that might be offensive or hurtful to others. And if you're a haiku master who can sort of make haikus off the top of your head, we encourage an MCN themed or current event haiku to be submitted to this repository. But these 3 lines, they look good. So we can go back here, merge this pull request, and then Kevin's haiku is now included in the repository.
And Shell, if I may, it's 12:15 here in Central Time, and I think we can. I don't think we need to merge all of those pull requests. Let's see if we can get people writing some haiku and get those in too. So, do you want to skip out to? I'm going to call it our slide number 38, and where is, no, actually, I'm going to say it's our slide number 41, where we have instructions for people to start writing their first few, or I'm sorry, for everybody to write their haikus.
Yeah, I will jump to 41.
These are all the things we just did in GitHub. Those were backup slides in case that didn't work. So this is, I'm going to paste that into the chat as well. You'll see that that's a slightly different address, but that is that's the address where when you're logged in, I'm just making sure that's a different one. Okay. When you're logged in, you can go go to this address and add a file here.
So yeah, and the great thing about Git is that this is distributed nonlinear workflows. We don't have to do all of this in the next 15 minutes. So we'll wait for pull requests to come in. We'll merge a few as they happen. We can check back to this random haiku generator. When I refresh the page, it shows that there is a new haiku generated from the number of haikus that are included. I'll make sure that's in the chat.
And Shell, that also, you also have that set up to refresh every 3 minutes, right?
Yeah.
So it will do both.
Yes, it changes when new content is sent into the repository and on a regular schedule just to rotate through.
Cool. And I see 8 current pull requests right now. I don't know if any of those are new. Doug Peterson, look at that. So the very number 16 there is brand new.
Yeah, I think a lot of these are new. So yeah, we can go through and start merging them.
Thank you all for participating. Oh, thank you. Thank you, Diane and Chris, for noting the structure of a haiku. And you will notice from some of these older Basho haiku that he wasn't following that because he wasn't writing in English. You know, these are all translated, so they vary a little bit, but they still sound good when they're randomized. So
Charles and Shell, there's
Yes.
another question from Rachel in the Q&A panel. I'm wondering if you want to answer that now or save it for later. It's about, well, it's 2 questions. One, is there a way to follow other GitHub projects?
Yes.
And the other question is, if using GitHub to create a project documentation, what are the pros and cons of using GitHub versus creating a wiki to do version control?
That is an excellent question. I'm going to move that forward into our questions slide. Thank you, Rachel. And then we'll go back for the first one. Let me find our questions slide. That's not it. Good. Yes, you can, in a very similar way to how you follow somebody on Instagram, you can follow other GitHub projects. So you can star them, you can watch them. I can't remember the exact terminology. There's a watch and an unwatch in the interface. So you can be, in this case, I'm looking at my GitHub interface, and you can be notified of all conversations. You can be notified of new releases. You can be notified if you're mentioned directly. And so all of those are available in GitHub. And again, that's a GitHub edition on top of the Git base. And I see that Shell is adding pull requests like crazy in the back in
Yes.
this other screen. Thank you. And I have both the chat and the Q&A open. And Rachel, I've moved GitHub versus creating a wiki into our very last slide. So we'll get to that in just a minute. So randomly generated haiku, tried to add. Thank you. Thank you all for participating. This is actually working out well. Yeah, I'm glad we can watch Shell pulling this stuff in real time. I think that's great. What do you see, Shell?
I see them coming in. I think we've got about 10 minutes left, so maybe we should go back to the slides and keep working, but we'll keep merging in these pull requests later, and the link to this random haiku generator is pasted in the chat for everyone to check in on.
we'll post that on the Slack, and I'll probably tweet it and that kind of thing with the MCN hashtag. So we'll do all of that as well. Yeah, I think that's great. And Shell, if I have a minute, I will, if I see any haikus appear in the chat, I will bring them in through my interface, and I'll keep pulling them in. So back to presentation. And I got to rearrange my windows. Wrap up. Okay, let me catch up to you. So today we talked about Git. We talked about how GitHub is different from Git, and we did that very simple flow. And then I'm really pleased that we brought all those new haikus in, and that this is working in exactly the way that we were hoping it would work live. Because there's always a couple of technical glitches that you have to overcome. So, Shell, one of the notes we have here is, how is this working with your non-GitHub colleagues at MIA for collaborating on projects?
Yeah, so as a computer programmer for a long time, I've used Git so much that it just feels like second nature to me. It feels like everything should always be a Git repository, and that's not right. That's not necessarily a good approach to starting a new project, but we have worked on a couple of projects at the Minneapolis Institute of Art with a larger team than just the computer programmers, and had some really good successes. I think I saw Greg in the chat earlier. If you're still here, Greg, our choir publications are going great. We have a designer who's actually stepped into the role of a GitHub coding digital publication creator. And that workflow has been very successful. We have a few projects that are sort of internal CMSs that are managing data and content, where GitHub is it's a quick and dirty, I don't know, maybe not quick and dirty. That has bad connotations, but it's a very easy to get going with sort of CMS, content management system, where we set up exactly how the files should work, sort of similar to this haiku generator. And we've trained participants in those projects who are less technical, who are definitely not computer programmers, to write and edit this Markdown content and manage files within GitHub. And it's definitely a different approach than starting a wiki or starting a WordPress site to manage content. For our main website, we use WordPress, and WordPress has so many features that are specific to websites that we probably won't back out of our main website being in WordPress and start editing that content in Git anytime soon. But it's worked really well on the projects that we have tried it on. And there are a few projects where we tried it and it didn't work so well. So we moved the content from those GitHub repositories maybe back into something like WordPress.
Susanna, I'm trying to figure out why you're not seeing the same thing as I am. Create new files, add file.
Is she on the same, did she click on the link that's the tree link?
Ah, right. We're running two different links there. One contains tree in it, and that takes you all the way to the haikus folder. And one of them is the top, further up link in the repository. So right now I have, let me finish this, add file, and that turns into create new file.
Okay, I see a question here in the Q&A from an attendee. Would a cultural heritage institution that already has a digital asset management system use GitHub to archive for posterity the original image and video files for a particular project? What department position in your institution would manage ownership of GitHub? So that's two questions. For us, the technology department manages our GitHub. We have a few administrators on our account. Some technical, I'm one of them, and some of our broader staff for billing, handling billing and that sort of thing. And to the first part of the question, GitHub is probably not going to be a digital asset management system anytime soon. We mentioned earlier that there are ways to submit large, bulky image or video files. You do have to pay for that. And what GitHub is great at is tracking the changes over time in a project. And it can do that for images. If you have an image in your repository and then it changes, when you're looking at it in GitHub, it can show you on the left, here's what the image was before. And on the right, here's what the image is now after it was updated. But I don't think in the scope of a DAMS that might not be as useful. And if you're talking about putting original image and video files in, the file sizes could be prohibitively expensive once they get into GitHub. There are some projects that are taking Git and starting to branch it off into that sort of DAMS-like functionality. There's one that's very interesting that creates a storage system for large files specifically. And so I'm very interested in the possibility of that happening, but right now that's not what GitHub is really trying to do. So I think that is my answer to the question.
Cool. And Shell, I see that we have just 2 minutes, less than 2 minutes left. So let's hit our links and resources page or slide. And we'll get back to that one last question if we have time. But we should also say thank you all for joining us. Thank you, Shell, for stepping up and helping make this presentation super interesting in not very much time. So thank you. For me in particular, thank you for doing that. Chris, will you figure out how to move this conversation onto Slack, and we'll look for an update from Chris on Slack about that, and then we'll figure out how to tweet out, you know, a couple of links with the hashtag. I'll do that in the next little bit.
I'll create a Slack channel for this presentation, and you can it'll show up. You can look for it. Give me about 20 minutes.
Oh yeah, absolutely. Yeah, I'm sorry, I'm speeding up because we have a hard stop.
Yeah, no.
Right about 12:30. So we will figure out, we're gonna have to save these chats and these Q&As, and we'll bring those questions forward into Slack. Thank you all.
One last really good question,
yes,
if you have time, about did you answer that? We'll drop recommendations in the Slack channel.
Yeah, there's some recommendations, links, and resources on this slide, and we can put more into Slack as a useful place for people to go further with this if they're interested.
Okay. Thanks, y'all.
All right, 12:30. Thank you all.